Welcome to DWBIADDA channel. Please subscribe for latest training videos.
Hello everyone, welcome back to the lecture series on natural language processing. In the last lecture, we stopped at the point where I told you how we pre-processed our text, and we were actually able to pre-process it and clean it to quite a good extent by removing out all of the HTML tags and basically removing the stop words and some more punctuation marks which were also counted in as stop words by making another list of stop words. So I hope you're clear till over here. And now comes the part that we all have been waiting for, that is transforming your text into a vector, right? But before that, I would be splitting up my data set into train and test data sets so as to like look at the final accuracy that what we are getting at the end after applying the machine learning algorithms. But one thing that I would like to tell you at this point is that for me at this point in time, accuracy does not matter at all, because we're only learning the things and not doing it in a proper way or like how it should have been done. We're doing it like how it should have been done, but not following the rules or like actually like going into advanced stuff. So I'm just telling you on how to implement the same, right? So like the sentiment analysis requires much more deeper approach. Like these are the basic steps that we follow, but yes, cleaning requires cleaning to a good extent, and then like we need to check in how many positive reviews and negative reviews are there and all of that kind of stuff, like data balancing and stuff. But we are not doing this at this point in time, and we're only like learning how to apply things. When you are comfortable with all of these stuffs, we can actually move in forward to the advanced stuff and get some more tasks done on sentiment analysis. But for me at this point in time, accuracy does not matter, but I'm just using this splitting into training and test data so as to like enable you learn one more thing that might be helpful for you somewhere. So for this, we already have a like library implemented in sklearn, which is known as train test split. So from sklearn.model selection import train test split, and over here what I will be doing is xtrain comma xtest comma ytrain comma ytest is equals to train test split. Then I would have to pass in new x comma y comma test size. I'm keeping this as 0.2, that is out of my like 1000 elements or 1000 sentences. Like 800 would have been for training and 200 would have been used for testing. So 0.2, right? And which is basically like 20%, you know. Then random state is equals to 42. You can or you cannot specify the random state. It depends like on how you do that. Like I'm specifying it, but this is not a required parameter at all. So once this is done, I have now xtrain, xtest, ytrain, and ytest set up. So xtrain is basically 800 like sentences. Xtest is basically 200 sentences. Similarly, ytrain is again 800 sentiments, and ytest is basically 200 sentiments. And now comes the final point, like where we'll be applying our text to vector models. And first we'll start with the bag of words approach, which we'll be implementing using count vectorizer. So without wasting much of our time, let's get started on this as well. So for that, we already have a library set up, as I told you, which is known as count vectorizer. So importing count vectorizer is very easy. So from sklearn.feature extraction .text import count vectorizer, right? Then I would have to create the object for count vectorizer, which is basically cv is equals to count vectorizer. And then like I told you, we only take those words which have a frequency greater than that of like some x values. So for that, we specify this using min_df, which is a parameter. So let's say min_df is equals to 40. So or let's say 30. So we are taking only those words which have a frequency greater than that of 30, right? So we would be doing the same, and let me just run this piece of code for you. And then new x is basically cv.fit underscore transform, and then we would pass in new x. So this will actually create the sparse matrix for me. Sparse matrix is a matrix consists of zeros and ones. It can be twos and threes, but majorly which has a lot of zeros and less number of elements set up. So let me run this piece of code for you as well. And then if you're like interested to see like what features we are using, so we already have like something like cv.vocabulary, which could be useful over here. So as you can see, like these are the words that we would be using, like watching, school, watched, played, wanted, won, art, form. So these are not the numbers. I mean, these are not the frequencies. matrices, but these are the index numbers at which they would be actually marked upon. So let's say your scene, like the word scene, if it appears in the sentence, would be actually at like index number 462 of the vector, right? So let me just give you a hint over here. So let me just print something like x of 0 or new x of 0 dot to array. So this two array thing would actually give me like how my count vectorizer looks like. So you could see like this is how my count vectorizer looks like. So it's a matrix consists of zeros, specifically zeros, and then ones, twos, and threes as well. So there is, I can see there is one over here, there is one over here, and there is one over here as well, and again two over here. So these are the words that are appearing in the sentences, and these are the words that are not appearing in the sentences. So basically, like if I actually print this, like print length of something like this, like x of 0 to array, I don't know if this would work or not, x of 0 dot 0 to array. So okay, so let me just do something like temp is equals to new underscore x of 0 dot to array, and then I could actually give you a complete example. So to array over here, and then if I print temp, so you would actually see something like this is the vector that we're basically getting. So what will happen is that the length of every vector would be same, like every sentence or x of 0, x of 1, x of 3, that would actually be same. And then like it's if the word is actually appearing twice, it has been like I already showed you or give you an hint at how index basically looks like, right? So let's suppose this index, so if in this index a particular word is appearing and it's present in that sentence as well, so it's replaced by 1, and if it's not, it's then replaced by 0 over here, right? So we have a total of 9, I don't know like how many elements we do have, so let me just check. So print temp of 0 and then it would be length, right? Length of temp of 0. So if I just print it over here, you could see that we have 623 words. So 623 words will be present in each and every sentence, or each and every what I could say, each and every text basically, because 623 words have a frequency greater than that of 30, and we're actually taking those frequency only. So min df, like we have actually used 30, and then 623 words have a frequency greater than that of 30, and so like we then assign those numbers some random indices, and if at those indices those words are present in that particular text or not, we are giving it a 1 if it's present, and if it's not, we're actually giving it a 0. And if they're appearing twice or thrice, we're actually presenting it by number of times they're actually appearing. So x of 0 would have a length of 623. Similarly, x of 1 would also have a length of 623. If you don't believe, let me just run this for you. So temp of 0, and as you can see, it's like 623 as well. So everything has a length of 623 because this is what when min df we have actually like used, and this is how we actually work with bag of words model over here. And now if you're interested in actually applying some machine learning models to bag of words model, we can do that as well. Would actually look out for logistic regression and naive Bayes. So let me just do this for you. So from sklearn dot linear regression linear model import logistic regression. So logistic regression is basically something like your classification model, and because the sentiment analysis is a classification problem, we could basically use logistic regression over here, right? So I guess like we have done a mistake over here. Let me see if this is a mistake or not. Yes, the mistake that we have done actually is we have passed something like new x to fit underscore transform, whereas we would only have been required to pass in x train, because like training for like we have actually splitted the text into training test and testing set. So we were actually working with training set and not with the testing set. So there is some error over here. So that means I would have to rerun this piece of code so as to like replenish everything. So let me just run this over here again, and this will actually take a very little time. So it should be x train and then over here x train as well, right? And if I just print x train over here, so you would actually see this will tell me that this is a sparse matrix consisting of something something. So as you can see, this tells me like this is a sparse matrix consisting of 800 words, like 800 into 465 like words, right? And total of 33516 have been number of elements are present. So how did we get something like 33516? It's basically, I guess, 800 multiplied by 465. No, it's basically like the number of elements that are actually present. This is not the multiplication, but the number of words that are present, right? And then let me just do something like x train to array, and then yes, so 465 total words were there. And like first it was 623 when we were using new x, but then we actually use x train and not new x over here. That is why this actually changed. So things did not change, we just only changed something from like new x to x train, because like we have already divided our dataset into x train and x test and all of that kind of stuff. So now let us apply logistic regression model over here. And logistic regression, so I would just create the objects for logistic regression. So LR is equals to logistic regression, something like this, and then LR dot fit, and over here I would actually pass in x train and y train. So x train comma y train, so something like this, and this should basically work. And as you can see, like this has successfully given me the output. And then I could basically use something like LR dot predict, and then like pass something like x test of 0 or something of that sort to actually get the output. But I hope you understand like how we actually use count vectorizer over here. Like count vectorizer so as to create a bag of words model. So if you're not comfortable, let me just give you a quick like recap. So for count vectorizer, like we have to specify something like min df, which is the frequency above which we will be considering the words, and then words will be picked up from the bag and assigned some random indices, and based on these random indices the vector would have been formed by taking the count of words that are actually appearing in the particular sentence. And then we actually apply models like logistic regression and like need base so as to this vector so as to get the final output. So I will stop this lecture over here with the hope that you have understood something and gained something important from it. See you in the next one.